Perfect. So yeah, look, thanks for kind of taking your lunch to join us today. For those who don't know kind of WeShape or kind of who we are, so we're a DevOps cloud native technology consultancy. Luke, if you just want to go on to the next slide, please. So just kind of a bit of a high level. So we're a bit of a unique operating model. So half of us are ex-industry technology recruiters, predominantly focusing in the kind of DevOps cloud infrastructure domain, and half of us are technical consultants. And the reason why it's quite a unique operating model is our skill sets very much complement each other when we work with our customers. So identifying essentially their pain points, building bespoke solutions, and then scaling teams at scale to kind of alleviate these kind of particular pain points. WeShape as a business, coming up to about 2.5 years old. The team's about size 40 to 45 now, so kind of growing rapidly. And here's some of the kind of customers we've supported, I guess, over the last 2 years, which seems like it's been about 5-10 years since the start. So look, can you, next slide, please? Where our kind of solutions cater for the market is we support anywhere from kind of organizational or technical advisory. So right at that kind of inception stage where you might look for a consultancy for guidance or further due diligence. We then have kind of two implementation models. One is more of a squad-based solution, which is kind of pre-gelled teams, deploy specific for product delivery, or where a customer might have a particular capability gap, is we bring in SME consultants. So that could be around kind of certain database estates or containerization solutions. We have particular SMEs who can alleviate those pain points. And then the key thing, and very much aligned to WeShape's agenda, is about self-sufficiency. So how do we upskill and train your team to be self-sufficient on the ongoing basis? You can go next slide, please. I guess one of the key differentiators from WeShape is you might be aware of some of the communities we're behind. So London DevOps, Jack, who's also on the call, is one of the co-organisers of this event, quite an established event across London. It's got about 8,000 plus open source specialists. So if you are ever interested in kind of hosting an event or speaking, or any of your team, we are very well connected in this kind of area. And then on more of a leadership capacity, which could be of relevance to a lot of the people in this room, we're behind London Tech Leaders Forum, which is about 1,000 plus C-suite kind of head of function community. So we have a content platform and we have quarterly events, all with kind of CIOs, CTOs, and compared by the group CTO of Naked Wines, David Crawford. So great insights, blog articles, but I'll share that and distribute the link after the workshop too. I guess the final slide in the introduction. Where do we support customers and where could we be at the most benefit? Is one is guiding and helping shape your technology strategy. This is more around kind of process tooling methodologies, right through to kind of, as I mentioned, the implementation side. And what we're very fond of is kind of blended team model. So not about how does WeShape take complete ownership and you become reliant on us as a business. It's more about how do we work and combine and blend our teams with yours, get you up to speed, that knowledge IP transfer. So the end goal is for you to kind of take it forward and take ownership of the direction through our guidance. But now I'm just going to pass you over to Luke, who's going to kind of give a bit of an overview about the agenda at kind of DevOps, what's the business value, what's the adoption techniques. So yeah, Luke, over to you.
Great, cheers. Probably should have put the cover slide at the next point again.
Yeah.
Grand. So yeah, I'm Luke Ashbrown. I'm one of the senior consultants with WeShape. I was a developer for about 10 years, turned to platform engineering since about 2014, doing DevOps, SRE, and then cloud native containerization type approaches. I've done an awful lot of audits and sort of a milestone and roadmap sort of generation for our clients. And that's kind of the summary of me. On the human side, I love space and rugby. There you go. So this talk is really just a kind of a run through on the principles of DevOps. So let's go into the agenda. Yeah. So the principles of DevOps. It's not something super technical or high or low level. This is really about sort of studying why it's a good thing, where it came from, what kind of effects or needs you'll have to implement it in your organization. Touch on tools and technologies and general adoption approaches for your business. So, I mean, to start at the beginning anyway, the overview of DevOps. So, where did it all come from? Well, I don't know how much, obviously, the room already knows about the topic, but we're going to run through some of the fundamentals. The old way, the the old way was kind of that trickle down process. Business identify a requirement, they throw it over the wall to their app team or the developer, the software teams, who'd build the feature, who then throw that resulting artifact over the wall to an ops team, who are expected to take whatever they're given and make sure it runs and is stable and actually serves customers. Of course, the traditional model often has its critics. An awful lot of problems in communication not happening between these silos, and it was usually based on things like this old waterfall model, a slow, long, drawn out process of upfront design and implementation and testing before it ever sees a running environment. And the hope is that everything was planned correctly and nothing ever goes wrong. Um, and there's a great story about uh, showing my space side again. One of the early NASA missions, they sent a capsule up into orbit, and they had this whole mission plan. They spent uh, years developing the capsule, years training the astronauts, and they sent them up into space. And it was the first spacewalk. And the astronaut went out into space, enjoyed it greatly. It was fantastic. And then when he was finally told to come back in, because he wouldn't, he was enjoying himself too much, uh, he came back into the door and he tried to seal it behind him, and it would not seal, despite all the engineering preparation, all this upfront design. And it took about an hour and a half of leverage and elbow grease and physical forcing to get this door to seal. And finally, he was able to get back into the capsule. And they had a follow-on step, which was they were meant to deposit all the EVA equipment into that airlock and dump it out into space, so they'd be free of the equipment and the weight for re-entry. But instead, they had to stuff it all down into the foot sort of area underneath them, and you know take a risk that they wouldn't be able to close that door if they opened it again, and but deal with the extra weight and the cramped conditions and re-enter with that risk. So what happened at the end of that was they analyzed the situation, uh, had a look at the door, and they were thinking, oh, did we implement it wrong? Did we get the design wrong? Was there something, that we could have done better? And in the end of the day, it was something that there was no way they could have known about until they were in an absolute vacuum. Uh, it turned out to be what you call it, cold welding. And it's a concept that the metal surfaces that were in contact with each other didn't have an oxygen patina, which was scraped off when they opened the door. And when they closed it behind them, it sealed up again. When they reopened it to let them back in, the surfaces had welded to each other because of the nature of cold welding. And this is something that only happens in an environment free of oxygen. Um, and it caused some damage to the door, but ultimately just caused them an awful lot of risk that they wouldn't be able to seal it properly again. And this was down to this years and years of upfront design and implementation without any real environment testing. And now they don't have the option of going to space and then re-engineering their solutions without massive risk out in space. And that's where I say we're not NASA. We are a bunch of technology businesses. We have the luxury of emulating our environments, of creating something like it. And also that we can rapidly and easily build and test. So that's where, these problems come out. You have this sort of old environments which are stuck with the old silos of knowledge and the conflicting motivations of different teams. They the software engineers want to produce code, they want to get features out because that's maybe where they're financially motivated. Their bonuses are based on performance. The operations team's performance is based on stability and lack of downtime. So they get these sort of blockers and conflicts with each other. Now the software engineers saw that they needed to move faster, so they came up with this agile process, this brilliant thing that said, right, we can do extreme programming, pairing, test-driven development, loosely coupled components, decomposing things architecturally so that they're not so monolithic. and they all just were aimed towards going faster. So you end up with this wonderful agile cycle. You get your requirements in, you design, develop, and test in a cycle until you're happy, and then you just throw it out the end. And problem with that was the ops guys were still getting the releases thrown over the wall, and only now there was more of them more frequently. So they needed a process, something to close the loop. And they really needed to stop this sort of onslaught, this flood of change coming at them, or to manage it better. And also, they realized that working in an opposing points of view was just a negative, pattern. So to work together to implement a cycle that actually is implemented by both sides of that arrangement, of that partnership, uh, means that you get the test and analysis cycle that was in the earlier agile process is now extended to feedback from the actual deployment process. So DevOps doesn't really have a fixed definition. There's some principles that have been used to try and encapsulate what it means, things like CAMs and 7 pillars. But they all tend to hit on some similar concepts. Collaborative culture, like we said, the ops and the dev teams, they have to work together. They have to understand that one's motivations might conflict with the others unless they align, unless they realize that they're both serving the same goal: get features to customers and don't have downtime. They both want these things. They just have to understand how to do it together. Um, and then the different principles that are used to implement it. One of them being automation, and that's to sort of avoid the manual steps that those ops guys have to go through to get that new product, that new feature out into an environment. And secondly, uh, to use things like lean operations and which is all about I guess rediscovering the requirements of your process as time goes on, and also measuring and sharing those results with everybody. Um, and then on 7 pillar sides, it's about the same kind of collaborative culture point of view, the design for DevOps, which is about your architecture suiting the needs of automation and measurement, and rapid deployment, and then using continuous integration, continuous testing, and continuous monitoring. Those kind of end up in a continuum of you want an automated process to build your artifact, your software feature, or your service that you're redeploying or introducing, and you want to test it without having to do it yourself. You want the system that's doing that build to also test it. You want the system that's testing it to also pay attention to the metrics it casts out. And then when it's all past that sort of quality assurance cycle, you want to make sure that your infrastructure that's going to host it isn't something you have to do manually. You want to automate as much as possible. And then finally, you want to achieve a continuous delivery, something that's an end-to-end process. You don't have to worry about your build and test and deployment out to production without a lot of manual interaction. So these concepts really were just sort of a way of encapsulating what I see as kind of the same goals. The same goals are just universal. We want to move faster. And this is the promise of DevOps. We're going to move faster, deliver more often, and we're going to realize value sooner. The focus on delivery of value to customers. I mean, this is one of these things that is worth stating so that you don't get bogged down in the technical, internal, project-oriented kind of focuses that teams can get into. If it's a project, it's probably the wrong thing. If it's a product and it's customer value, that's probably the right thing to focus on. You want to reduce the failures, the outages. You're moving faster, you're doing more things more often. So you want to have certainty around that process. So you want to basically speed it up so that you are, reducing that risk of failure. And then the last piece is the monitoring for stability and outcomes. Without observability, you're not going to know how it's performing. You want to see, that the technical metrics stay good, but you actually want to see that you're achieving the sort of business goals, the key performance indicator for your team, that the system's not going to run out of space, or it's got it doesn't have flapping sort of memory and CPU usage. but also that your customers' activities are monitored, that they clearly know that the metrics that the customers are going to be emitting are going to relate back to those kinds of metrics as well, and those kind of performance indicators. So we'll get into more of that later. Ultimately, anyway, if you manage to do all this, people will be a lot safer, a lot more certain of the process, and you end up with a happy engineering staff. And a happy engineering staff is a really good thing because they feel empowered to make change. They feel certain and secure in their role, and they're far less likely to leave. So you're going to get retention. You're going to get an awful lot of value from not having to rehire. So there's a kind of a what you call it, a undeniable value in that, because not everybody knows engineering hiring is an absolute nightmare. So how does this all kind of relate to that speed of delivery? Um, so the goal is faster iteration. In the typical model, you had this. I've got it as bars, but you can think of it as a curve. You've got a flat line and then a big spike of value delivery at the very end of a long drawn out process. The longer that is, whether it's a year, a half a year, a quarter, whatever it might be, sort of a slow rate of release. You've got no value until that release occurs, and it's a big release, it's a big bang. So the goal of DevOps is to flatten that line out, make sure that you're constantly delivering value iteratively, adding on bit by bit rather than doing it all at once. So that does two things. First thing it does, you've now created a volume of value and a continuum that didn't exist before. Every time you release value, that's potentially money. That is potentially sales. That's potentially a business line that you can open. It depends what your values are, but every step of the way, you're delivering something that could be converted to actual income, revenue. So, so you just want to uh, realize that every time you write code, that code has value tied up in it. And until that code is released, it's no better than code you haven't even written yet. So at the end of the day, you want that code out as close to as when it was designed to release and achieve production. So I mean, it's all about that move from older styles of waterfall or gathered up releases, and moving to this DevOps iterative rapid release approach. So any delay to that delivery is just value lost essentially. So the other side of it is the risk. I mean, the risk reduction of this process really sort of piles up. The more that big bang occurs, the bigger that risk is, and then the mitigation of the outage that can occur based on the number of factors that are causing issues can massively extend the recovery period. What it means is that your expected delivery date isn't the date you released it. It's whenever you manage to resolve all the issues that came out of that release. And that can mean one big unpredictable delay at the end of your actual project. The change is to break that risk back down into smaller little chunks. Every time there's a release, you've got a manageable, small, and more digestible set of changes that are to be evaluated. If there's a breakage, it's something that should be found pretty quickly. The mean time to resolution is that key metric that a lot of people refer to, and that's either in releases or just general operation. But in the release story, in the DevOps story, this is what we're focusing on here, is that you get that risk reduction. You might have one or two issues. The mean delay to your end goal, your end delivery date, may be nearly completely unaffected or only very slightly affected if there is any issues in these little changes. You don't have a big post-mortem process at the end of it. The other element that's really useful about this is that every step of the way, you're experiencing that risk, learning from the things that cause the problems, and you're also able to then expose that value and get feedback from stakeholders in that thing, so that you're constantly learning, you're constantly seeing value and assessing the value, the success of the delivery of that value as you go along. And that's something that anybody who's worried about the growth of the revenue or the sort of achievement of those goals is going to really value and really find important. So this is really sort of reiterating the sort of the reduction of those outages. Yeah, so mean time to resolution is the big term that's used an awful lot. It's one of those things you should measure. You should measure how long it takes you to register an incident happening and then get it to resolution in production. Maybe that involves a development cycle, it involves re-release, whatever it takes. But ultimately, you're going to reduce your losses from that downtime. And the funny thing is, you can really put numbers on outages. You know, one of the examples I went looking for was the 2019 November outage Amazon had, and they lost 2.3 million in sales in 13 minutes of that particular business unit. And you can do an awful lot to calculate what your outage cost per minute might be, just by figuring out the business unit or the product's annual revenue and just divide it by the number of minutes in a year. Now, obviously, very vague, very rough, but it's one of those things. When you do that with the Amazon loss, that was £200,000 a minute. So it's quite an expensive thing to have a downtime. So when you want to sort of look at what your tolerances for this stuff is, you can start with an estimate which is just based on the number of nines, they call it, uptime you want to ensure, your SLA, your service level agreement or service level objective. That gets into site reliability engineering, another subdiscipline of DevOps. But yeah, you can sort of set a budget on, can we estimate what the revenue is, and we have an estimate of one of two things: look at our previous outages, see how much we reduce it by, and you can count that as an actual income. You can say that's now improved revenue because of less outages. Obviously, that could be sensitive to seasonal, time of day, and the nature of your business and the customers using that system. But if you can sort of have a rough estimate, it gives you some sense of reportable value returning by doing this. So to get there, we kind of have to look at three main factors, in my estimation anyway, and a lot of people's estimation, that that kind of all contribute towards the DevOps goal. People, process, and technology are at that top level. You got to focus on your people, and that involves the organizational culture and their skills involved in the process. The process, of course, being informed by your business's culture and needs, but also can be quite well informed by tools you choose to inflict process on your teams. That's one way of putting it. And yes, the technologies, they can inform process, but they can also inform your people's technical implementation skills. What they need to know to automate what they have to automate, as well as influencing the process and the tracking of that process. But it's a unified approach. It needs to be across all these different pillars or tiers or legs of a stool, if you will. So what do we sort of focus on when we talk about these things? So cultural change. As a business, you sort of have to start by saying, we need an adoption strategy. We want to just embrace agile to start with, because as I showed earlier in that continuum, the software engineering systems, or sorry, the software engineering discipline came up with this agile methodology, extreme programming, and other things to iterate on their code faster. And that same project management approach definitely applies to operations, and honestly, it certainly can apply to business management as well. There's no reason it shouldn't apply to much more than just your software and technology teams. Excuse me. So as a business, you should experiment. You should pick a small group, and that's a key thing there. Small group. Don't do a big bang change across your whole organization. Choose a small group who maybe are enthusiastic or experienced, and actually, it's talking about monitoring and observability. Perform some pollings, for some surveys of your teams, and get their attitudes, get their impressions and ideas and knowledge about these topics, and that will inform you also about who to go to try this out, and then start iterating on introducing uh, these different approaches to adopt it. And then call them sort of enabler teams as a concept. I think I'm borrowing that from somebody, but yeah, there's that concept of, and you identify these enabler teams, test their approach, and measure the success they have with it. So what do you do? One way is to train them, and obviously training is going to return based on the effort or actual investment you make in the process. Your teams can be, told do DevOps, sink or swim. Just go out there, research on the internet, and figure out how it works. You could put a bit of money into some training courses that make them available passively to your teams, and to say, right, can you go and take some of these courses and just try it? You could then go this next step along, which is pairing experienced people with those who want to learn, or even hiring in, the sort of consultants and external experts who, or people who could really inform your teams how to do it. And that kind of maybe spans both, either the pairing shadowing approach, where maybe these consultants just join a team and be part of the process, or you have very dedicated intermittent training sessions with these consultants to help just sort of like develop the discipline in your business. Or you could go whole hog and you can have a structured program which seeks to set a bunch of kind of what would you call it, OKRs in a way, organizational key realizations. I forgot what OKR means again. Yeah, so like a goal for the business to say, uh, we want to have X percentage of the engineering teams trained up in this agile course, so that we have a standard and a sort of a baseline level of ability and knowledge in the business, and that can create quite a united front on how to do it. But obviously, it's probably the most expensive way to introduce those skills. But the more you put in, potentially the more you get out of it. So that's one of the approaches to doing that. I mean, the other side is, I wouldn't recommend going down the center of excellence approach. A DevOps is a whole organization effort. It's not, we put in a skunkworks team who do it. Like I said earlier, you don't want to create that sort of like one group who knows it and nobody else. So you really gotta approach it in a iterative but eventually pervasive approach. So quickly then, just onto tooling. There's lots of tooling in this industry. You probably heard of a bunch of them, and I've tiered them out into sort of phases of process. In the planning phase of that infinite loop of DevOps, the virtuous cycle. Um, you got planning kind of tooling. There's 100 different products out there. These are some of the main ones you see out there, though. So, Confluence for knowledge gathering, Trello and Jira for sort of ticketing and work process, and helpful for planning with your team. Uh, and that's very much the agile process piece in a way. Then the build side of it, getting good tools in the hands of your developers. That's the right coding environments, the right code tracking tooling, and honestly the right sort of breaching over into the test piece, the right unit testing frameworks and behavioral driven development and all the other techniques we can use to introduce a good quality of assurance that the code being produced will work well. And then it gets into this automation piece. Jenkins is the kind of the big daddy, the old boy in the market there. There's some great alternatives these days between GitLab and Drone and CodeFresh, GitHub Actions, and various other players in the market. But Jenkins is one of those kind of like pervasive old tools that's still very widely used. And you're probably all fairly familiar with it. And it's about sort of following through on the pipeline piece there, which we'll get to now in a second. Artifact packaging is really important. when you've built the outcome of your build pipeline, you need to store it somewhere, and it's not just put it there and then use it. Cube is just one example, but that's a static code inspection and sort of a code quality tool to inspect the quality of what you've actually implemented. And it has a load of plugins to do a little bit more than that. And there are alternative tools like Aquasec or Snake or other sort of security assurance tools, as well as various other sort of like code quality approaches you can take to implement a real quality assurance layer, even past where your build pipeline ends. Um, I always find it quite funny is that there's a big movement of shift left concepts in the industry where you want to push the quality assurance further to the left of your actual timeline of development. I see efforts people trying to build Snake Aquasec and SonarCube into the developer tooling before it even gets to Jenkins. So that stuff has already happened. But of course, it's very hard to do that when your artifact only gets produced at the Jenkins point. So there's some interesting efforts in that area. But the principle is the same. You want to have a way of, without having to go to massive manual effort or do manual audits and things like that, that your code and your artifacts that you're pushing out to your environments are well tested, well, quality assured. And then deployment. I mean, this is the automation piece at the end of the build process that DevOps really leans on, and it's about saying we shouldn't be doing manual work. Some people say, DevOps means everyone needs to dive into production and be able to see things. And the truth is that's probably the worst idea ever. You do not want to give your developers, especially, access to your production environment of any sort. Give them monitoring tools, give them the logs, give them the metrics and graphs, but they should not be able to hot patch a damn thing, and or even be able to tail logs directly on a box. That's not the idea. And an awful lot of that has to do with making sure that your automation, your orchestration of the environments is really solid, and using the right tools, the right platform stuff. I haven't put in cloud environments like AWS or GCP in there or Azure. It's really a case of the tool that deploys your environment. Maybe that's Terraform because you're doing VMs. Maybe it's Kubernetes because you've gone that cloud native containerization route. Uh, and then of course at the sort of VM or server, even hardware server orchestration level, you want Ansible or Puppet or Chef or Salt, one of those configuration management tools to really own the setup of the box and the deployment of the software there, if that's the piece you're going to manage with configuration management. And without that assurance, without that certainty, you don't get that confidence feedback to your team that your environment's going to be rebuildable, that if something goes wrong and we need to redeploy, there's not any manual process. You get the operations team going, we don't want so much change. We're going to introduce this thing called the change management process. It's the worst idea ever as well. So that really leans into the next slide, actually. The monitor piece, there's some great modern tools these days. Elasticsearch, Kibana, the ELK stack or EFK stack, as it's sometimes referred to now, which relays the log lines out of your applications and other components out to an indexable database and gives you wonderful display and interrogability of those environments. You also have commercial offerings as a service like Datadog, or Splunk and things like that will do all that work, so you don't have to host those tools. But there's really times when it's actually quite handy to host them yourself. Then the metrics and counter side, Prometheus is kind of very much the dominant force these days. It's taken over from StatsD and the old I struggle to even remember the name of it now, from about 2014. The metrics tooling there, and Grafana has become, it was a fork of the Kibana front end that refocused purely on metric side rather than log side, and that's your counters, your timers, your sort of like one of the really important things, almost the first line, the first thing you should be monitoring is the exact counter and frequency of events in your environment. That's what will actually feed things like your key performance indicators or your OKRs or other sort of things you want to measure. Um, so, so there you go. So the pipeline is kind of the key piece here in a way, you know. So this is where the automation piece usually really has a home. You know, and it can go through different phases of maturity. And this is also one of those key indicators of your organizational maturity. Are you building automatically rather than getting developers to push out their build manually? Uh, Obviously, it's less common these days. And most enterprises even now definitely do continuous integration. But it's that sort of like, where are you on that continuum, that journey towards real DevOps maturity? And your continuous integration piece really just produces a tested artifact at the unit test at least level, or maybe a bit further. Uh, but then what you want to do is you want to look at your deployment pipeline as a continuous chain towards your production environment. And anything that's not automated, any step in that sort of sequence of events that's not automated, uh, is a break in that chain, that friction-free flow of your software out to your environment. So you want to invest in things, skills, technologies that enable you to remove the manual process from any of these steps. And at least with a bit of care, it's certainly worth the investment. Um, the faster your system achieves that ideation to production deployment of a feature, an idea, a change, uh, the faster you realize the return on value, or the realization of value from that effort. And that is, you know, every day that it's held up is lost money, if you're able to look at it that direction. Or it's every day you gain in that ability to deliver is gained money. And it also sings to that change in mindset as well at the organization level, um, that operations in IT, it's not a cost center. It's something you have to look at. It if we improve it, it makes us money instead of costing us money. And it's that change of mindset from, you know, we have to spend money on operations to do our business. No, what you want to do is speed up, spend money so that your business gets faster and can take advantage of the market faster and truly actually increase revenue. And so where there was no revenue and no the scale of your business wasn't there, there is now, because potentially technology has helped you get there. Um, so remove those manual triggers, remove the manual steps every which way you can. Um, and ultimately, the pipeline turns into, has a couple of these interesting attributes. It gives you that feedback loop on, you know, I run the pipeline and I can see every step of the way that it worked, or it failed, or it otherwise is a problem. But it's a single point of collaboration between your software teams, your operations teams, your, metrics teams, if you have people who focus on that, like SREs. And it's a place where you can emit metrics. It's a place you can really sort of like get that complete view of what the workflow end to end, idea to production, or just incremental improvement every time it comes in, how it gets out to an environment. So it can really crystallize exactly how your technical operation is working. And so it has a massive importance in the DevOps kind of practice. And the more you run that pipeline, the more often, the faster it runs, the more often you get to use it to get something into a production or any environment, the more confidence you build in your process, and the less your team are worried about downtime, the less your team are going to, you know, do a release over the weekend because that's when apparently it's done, and sit there without any days off because they're freaked out that something's going to break. And that just stops happening. And if you can get it down to hours or days, you know, between the latency between releases, that confidence just will grow and grow, and it stops being a concern. Everybody actually just goes, oh yeah, as long as releases go out, it's fine, you know. It's almost like, no, we want more releases, we want to go faster. How do we speed up the releases? Hey, we've only done 2 releases today, can we do 5? You know, can we go faster? And those kind of KPIs start signaling the maturity of your teams, the maturity of your organization in this workflow. So architecture kind of has to suit all this. So DevOps architectures kind of, I guess the traditional migration was from your big old monoliths that you develop, or the ERP system that you bought off the shelf and deploy, and it's a three-tier classical, application. You've got the UI, business logic, data access layer sitting in front of your database, and you know takes a big honking piece of tin to run, and you've got a lot of a lot of liability sitting there. Um, and the agile movement definitely informed the adoption of the microservice architecture, where you break all that responsibility apart. And that also meant that each release of a component, each microservice, was this atomic release where it was just, something that could be released without affecting other components around it. It was a very important part. Don't do fake microservices. Tightly coupled microservices are not microservices. They're just a distributed monolith. So you really have to make sure that when you do microservices, the discipline is done correctly. One release should not require other releases to happen, short of actual API version changes that are introducing new features. But ultimately, you should be able to freely and independently release each microservice. Each one should hopefully be able to scale independently too. So, and if you do the 12-factor philosophy of 12-factor applications, that scaling should be horizontal per microservice, not universal. And that'll allow you to completely decouple those concerns. But of course, we don't live in pristine, idealized worlds. We have to deal with a bit of both usually. Uh, and things that haven't been scaled, like the database layer hasn't been scaled very well yet. And we end up with something like a strangler pattern, where we need to sort of evolve away from the monolith. We can't just big bang change it. And that's against the philosophy of DevOps anyway, big bang changes. So have your monolith and then start interacting with the monolith from your microservices. Start replacing segments of functionality uh, where the monolith doesn't necessarily have to own the entire process, and break it out into your microservices. And over time, you should be able to follow the story of the strangler ivy that strangles a tree that the seed was landed on by some bird, and basically envelop and ultimately suffocate that monolith out of existence. Um, and that allows you to do it slowly, iteratively, with experiments and testing, and without worry that you've got that big tick change again, that long wait with one final realization of value at the end. One thing missing from that, I suppose, is a router in front of all of it, something that can say certain requests go to the monolith and certain requests go to the UI or an API front end for our microservices. So yeah, so that's kind of the migration approach for that. One of the other parts of the adoption is going to be monitoring. We've talked about it before. We've got to see what's going on. We've got to understand that if we can't see how the process is going, if we can't see what's happening, we're going to be operating blind, and we need to have a sense of, did we succeed, and then change strategy more often. And that's the agile process as well. You take the requirements, you do some experiments with it, and you see if it works well, and then change the requirement based on feedback and feedback loop. So we've got to add all the monitoring to all the different stages of developer time, build process, artifact deployment, and then operational, incidents, outages, events, and the right sort of resolutions to those things as well. But so measure as much as you can, but recognize the value. So the value is really coming out of where you focus. You don't look at things in isolation. You don't look at single metrics and go, right, we're just going to like focus on the metric and drive it up. You got to have the sort of if you ever done a value map exercise where you kind of go, what's the customer value and how does it trace back through all the dependencies behind it? So you can trace the dependencies to deliver a value. So be customer focused. Start with the value that you're going to deliver to your customers. Measure outcomes. That's things like sales conversions, or if it's an internal product, maybe it's like software engineering teams actually implementing a Jenkins pipeline. So the success of adoption of your actual Jenkins platform or GitLab or whatever you're going to use. And use the smaller metrics, those intermediary metrics, as sort of like lead indicators for other things. That if you see improvement in those indicators, you should see a correlated improvement, perhaps in defect rate or incidents, outages. Um, or you can use it as a driving force to push teams, since they can't see the end to end, they can only see the metrics that they can directly affect. So you can use it as good guides to push teams to do better, but it should all be informed from that customer end point. uh, and the end to end things are actually probably more useful than those little lead indicators, things like ideation to production time. How long does it take from when somebody says I got a feature to it actually arrives in a production environment? If you can trace that, being able to trace that is probably a good sign of maturity of your organization in adopting these practices. So there's a lot to be said for that. Um, so the challenges around it, organizations will often say, let's do DevOps, and they expect results change very quickly, immediately. Often you'll see that the adoption value return is a bit of a J curve. You'll end up seeing even a dip in productivity, as you're moving from an environment which is uh, possibly got lots of skeletons in the cupboard, and you're revealing them, and you're having to resolve all the tech debt that comes with those skeletons as you migrate your architecture or you implement better practices. But the problem is that without a good foundation, those practices just are going to be really difficult to do. So you're probably going to see initially some loss in productivity, but the uptick is afterwards, is when you really start seeing value, is when you also get a sense of, oh, we've actually got a lot less tech debt now, a lot less liability. So it's another one of these things to monitor. You sort of say, when we see productivity rise, when we see our developers start doing better, our engineers and operations teams doing better in whatever KPIs we can identify, uh, then we can see that this process is bearing fruit. Um, and then we can start looking to up the rate of experimentation and change in the company. Um, don't neglect testing is one of those ones. Oh, sorry, I've skipped over missing elements. Yeah, sometimes companies will just go to a vendor and go, give me a tool that does DevOps, and they get a tool, and it's like, all right, technology is the solution. There we go, and they ignore the culture, the people, the training. They just go, right, we've got Jira now, go agile, go. So you have to invest in much more and deal with the training needs, actually upskill the teams, and invest in changing your architecture to suit what's actually there. The next point is, don't neglect testing. Often people will go, right, we're going to go agile, then we go microservices, and we'll do CI, and we'll deploy, or we'll push out artifacts really fast, and we'll go into production, and they neglect to create a kind of a baseline standard of QA, saying it's not just the unit tests. Do we have smoke tests for when the thing actually lands in an environment? Do we have those security audits tools in the middle after the artifact is produced? Can we do more than just smoke tests? Can we go towards canary releasing, or some other methodology that allows us to be even more certain of the quality of the release that's actually going to get into production? Testing is that sort of linchpin at times, and it's one of those prerequisites that if you don't do good testing, you're going to just introduce more bad stuff into production faster. So it's not really the result you want out of DevOps. Also, it's not one and done. You don't just have a beginning, a middle, and an end. You've done DevOps. You have to continuously iterate on everything you do, and all the time it's about optimizing how fast you can get value to production and make sure that you don't lose because of issues, stability, and other concerns. And yeah, that just takes continuous improvement. It's a business lifetime long pursuit. Um, and another element of it is silos can be hard to break down. You're going to perhaps fail from time to time. You're going to be stuck trying to decompose that old legacy system, or you've got that key man who only is the only one who knows how something works or is built, and to try and figure out how to get around that. Sometimes it just comes down to making sure that those siloed people do get included in this agile process and start to learn the techniques, introduce new members to those teams that have the exposure to the process, and start to start to bring the informed perspective into that silo, and it will decompose over time. And of course, when you create your enabler teams, I think I touched on this earlier, avoid creating a new silo, just this one team that knows how to do it, nobody else does. You want to dissolve those enabler teams over time, cycle people out of the team frequently. And the trouble is that they can't be that floating coach, because often when you create your enabler team, I'm thinking pretty much always, they're going to have responsibilities already. They already have a product or a component of your services that they own, they have to maintain. So expecting them to just turn into coaches isn't going to work. You're going to have to use them as a team to experiment with the process, since they're going to be doers. They're not going to be just coaches. And then supplement their team with additional resources so that you can cycle those people out to other teams and start distributing the knowledge over time. And it's a process over time, not the immediate big bang change either. So that's that. So, I mean, finally, just start. Do what you said. Just choose that business unit, a team, a product, whatever it is, and experiment with the process. Get going with your agile. Make sure that it's there, and iterate from. Do iterative experimentation from the top. That's just it. Your management team needs to agree with this philosophy. Needs to say, yes, this is how we can operate at a technical level, but perhaps and preferably also at a business level. Can we actually make proof of concepts? Can we do MVPs at a business level? Can we MVP an entire product? Whatever it might be, just to bring the philosophy home to the whole company, and not just have it something that's bubbling up from the bottom under. So I think that's about everything I have, and just in time too.
Cheers, Luke. Thanks for that. I'm just conscious of time, so thanks for the presentation. If anyone has got questions, I've put Luke's email in the chat box. You can ask her direct as well. I'm conscious some might have to drop off at half one, but has anyone got any questions they want to just quickly fire across now? Feel free to just unmute.
Yeah, I would have one. So is it worth adding resources for DevOps before having your first public version out of your product?
Say again, your first.
Let's say you're working on a piece of software, yeah, before having the first version out publicly available. Is it worth investing in DevOps?
Yeah, I mean that's a tricky value kind of judgment, isn't it? It's like what are the what are the imperatives of your business? If you can budget for it, and you will almost, and you don't have too much legacy already, like you said, if this is a new product, it's almost one of the best times to invest and engage with agile and DevOps. Make sure that you take the philosophy training point of view to just make sure everyone is informed about how DevOps works. If you're in a startup or something like that, or an internal startup, like an internal team, it would almost behoove your business to use a new product team as a great enabler team. They've got no legacy to worry about, so they can really just engage with pure automation, engaging with pipeline delivery, continue trying to do something like actually achieve continuous delivery. And that team can become an incredible source of that sort of dissolving the members out into other teams around the business and start informing the rest of the staff. So yeah, I mean, I don't see many cases where engaging DevOps that early would be a bad thing in any regard.
Yeah, okay, thank you. And one more question. Is it recommended to use the DevOps monitorization for getting business insight, or is that only for alerts in case something is going wrong and you have to intervene? Or
oh no, business insights are just as well served in terms of tying sort of some technical metrics can relate back to business value very clearly. Maybe it's the mean time to delivery of features, maybe it's the mean time to resolution of your incidents, and things like that. These things can absolutely tie directly back to business value. So yeah, your management team should be paying very close attention to these things, and be invested in creating metrics to follow. and designing metrics that can help them make decisions, for sure. So yeah, I don't see any argument against that either.
Okay, well, thanks a lot, Luke.
Cheers.
I'll probably drop an email, because I was just going to ask about, coming into existing organizations with a quite fair amount of existing technology, and call it legacy or not, but systems and processes that maybe in a sort of regulated, also in a regulated business, whether you saw the greatest pushback from the technology teams or from from a general sort of cultural perspective.
I've been in an environment very like that more than once. The most recent one I can remember right now would be the financial regulator, the Bank of England. And talk about a regulated environment. We were introducing Kubernetes, and it took some considerable willpower to deal with the networking team, because they didn't like rapid change. They were that ops team that said, you got all these changes coming in. We want a change management process. We want to formalize the bureaucracy around what you're doing. And sometimes, you need to adhere a little bit to that so that you can at least formalize the process. But you have to push for automation all the way through, even these teams that are resisting. And it's best to work with them, not against them, for sure. You have to help sell the value of this automation to those teams. If they can sort of say, we can thin that layer of approval of change management because we like that there's less toil. I mean, that's a good thing. They still want the regulatory approvals and things like that. I had a similar problem in government work as well. You get these network teams or DBAs or these environments that don't necessarily have to always be rapidly changing all the time, because they're just the sort of the tendrils, or the web of connectivity between the applications that are changing rapidly. But as time goes on, as infrastructure automation gets stronger, as we go into the world of Kubernetes, you start seeing components of your system reach out to those dependencies, create new databases on the fly, change schemas on the fly, reach out and change firewall rules, preferably not, but possibly, or change the host mapping of HTTP host filtering, things like that. And if those things are SSL terminated at the edge of a firewall because that's how the network team do it, it becomes a blocker when you need to introduce a new subdomain or a new host onto a service. So you get an awful lot of challenges in working with these people. They're dependencies, essentially. And the more you can orchestrate out to dependencies, the inversion of control rather than the top-down control of your environment, the more healthy, the more certain and confident you are in change, because you can do it more frequently. That's back to the same values of DevOps. More frequent change basically equates to confidence in your system and certainty that you won't experience as many outages.
Yeah, I guess it's about making sure that people see where they add value rather than where they've traditionally done that, how they're still utilizing their skills and experience, but they're not doing some of these low-level tasks that can and should be automated.
So it does definitely takes some interpersonal talent to get that across, for sure.
Yeah. All right. Thank you. That was really good.
Brilliant. Thank you. So, anyone else before we sign off?
Perfect.
Nope.
I think that's it.
Great stuff. Okay, great, guys. Yeah, like I said, email any further questions and we'll gather them up and maybe write up a couple of answers to those, and we'll go from there.
Yeah, amazing. Yes, thanks everyone for attending. As I said, I've dropped Luke's details in the chat box if you want to message him directly for any questions about the workshop or any DevOps questions. Alternatively, just drop me an email as well. But we will follow up with a bit of a kind of summary about the business value and creation, just for you to kind of take away as well. So I will be sending that around probably tomorrow. Awesome. All right. Well, enjoy the rest of the afternoon. See you soon.
Cheers, guys.
Cheers, guys.